Good morning and welcome once again to another video lesson. Our topic for today is about converting a normal random variable to a standard normal variable and vice versa. Our objectives for today are the following. 1. Distinguish a raw score x and the standard score z. Number 2. Express normal random variable x as standard normal variable z. 3. Express standard normal variable z as normal random variable x. And 4. Apply the concepts of normal random and standard normal variables in solving real-life problems. For us to convert a random variable x to standard normal variable x, we will be using the formula for z-score. In solving real-life problems involving the normal curve, it is particularly important to convert a random variable x to a standard normal variable or z-score. This procedure is known as standardizing or standardization of a random variable, where a standardized value is called a z-score. A z-score is a measure of the number of standard deviations a particular data value is away from the mean. Given any value of x from a normal distribution with mean and standard deviation, to convert x to a z-score, you need to a. Subtract the mean from x, and second, divide this quantity by the standard deviation. And here is the formula. The formula used in converting a random variable x to a standard normal variable z is z equals x minus mean divided by standard deviation, where z is the standard normal score or the z-score, x is any data value in a normal distribution, mean or the population mean, this one is the mean, and the standard deviation. Let's start with example number 1. Suppose IQ scores are normally distributed with a mean of 100 and a standard deviation of 10. If your IQ is 85, what is your z-score? Round off your answer to the nearest 100. The z-score can be computed using the formula z is equal to x minus mean divided by standard deviation. So, let us have all the given, substituting the given to the formula, z is equal to the value of the x is 85, while the value of the mean is 100, and the standard deviation is 10. So, supplying all the given to the given formula, we'll have 85 minus 100 divided by 10, which will be 85 minus 100 is negative 15 divided by 10. It will give us with negative 1.50. Z is equal to 1.50. Example number 2. On a nationwide placement test that is normally distributed, the mean was 125 and standard deviation was 15. If you scored 149, what was your z-score? Round off your answers to the nearest hundreds. Again, our formula is z equals x minus mean divided by standard deviation. And from the given, our x is 149, the mean is 125, and the standard deviation is 15. Substituting all this given to the given formula, we'll have 149 minus 125 divided by 15. 149 minus 125 is 24 divided by 15. The value of z is equal to 1.60. Example number 3. The heights of teachers in Santa Catalina National High School are normally distributed with a mean of 150 cm and a standard deviation of 15 cm. The height of Sir Victor has a z-score of 3.25. What is the actual height of Sir Victor? Round off your answer to the nearest hundreds. In this example, z-score is given, while the normal random variable is unknown. To solve for the normal random variable x, multiply the z-score by the standard deviation, then add the mean. In short, we will derive a formula to find for the normal random variable x from the original formula. Take note that the original formula is z equals x minus mean divided by standard deviation. For us to solve and find for the value of the random variable x, let us derive it simply by cross-multiplying it. So we'll let the denominator of z equals 1. Cross-multiplying it will give us standard deviation times z is equal to x minus mean. Since our aim is to find for the normal random variable x, we need to isolate this one at one side of the equation simply by using the addition property of equality, adding mean at both sides of the equation. So this will be z times standard deviation plus mean is equal to x minus mean plus mean. Since negative mean plus positive mean is 0, what we have now is the value for the normal random variable x. That is equal to z times standard deviation plus mean. This will be the formula for finding the height of Sir Victor. Take note that the given are z is equal to 3.25, standard deviation is 15, and the mean is 150 centimeter. So the solution will be x is equal to z times standard deviation plus mean. Z is equal to 3.25 times the standard deviation is 15 plus the mean that is 150 centimeter. 3.25 times 15 is equal to 48.75 centimeter plus 150 centimeter. Adding these two will give us x is equal to 198.75 centimeter. And this is the height of Sir Victor. Example number 4. The time it takes for a cell to divide is normally distributed with an average of 60 minutes and standard deviation of 5 minutes. How long will it take for a given cell to divide if its mitosis has a z-score of negative 1.35? Let us have the given one by one. The mean is equal to 60 minutes. The standard deviation is equal to 5 minutes. How long will it take for a given cell if its mitosis has a z-score of negative 1.35? So z is negative 1.35. From the given formula, z is equal to x minus mean over standard deviation. It is obvious that the unknown is the value of x, or the normal random variable. For us to find for the value of x, again we will be using the formula x is equal to z times standard deviation plus mean. Substituting all the given to the formula, negative 1.35 times 5 minutes plus 60 minutes. Negative 1.35 times 5 minutes is negative 6.75 minutes plus 60 minutes. X is equal to 53.25 minutes. Let's have example number 5. Suppose you have the population values of 40 and 70 and that their corresponding z-scores are negative 2 and 1 respectively. 1. Is it possible to determine the population's mean and standard deviation? If so, what are these values? To begin with, let us first identify the given. Let x sub 1 equals 40 and x sub 2 equals 70. Then their corresponding z-scores are z sub 1 is equal to negative 2 and z sub 2 is equal to 1. In this example, we do not have standard deviation 1 and standard deviation 2, as well as the mean sub 1 and mean sub 2, since we are describing a single population. Thus, standard deviation 1 is equal to standard deviation 2, and that is equal to standard deviation. Same with mean sub 1 is equal to the mean sub 2, and that is equal to the mean. Furthermore, we need to review our algebra specifically on system of linear equation. So, we will use this given and substitute to the formula. And we will be using the formula x is equal to z times standard deviation plus mean. From this given, we can derive two equations. We have x sub 1 is equal to z sub 1 times standard deviation plus mean. X sub 1 is equal to 40 equals negative 2 times standard deviation plus mean. Our second equation will be x sub 2 is equal to z sub 2 times standard deviation plus mean. And this will be 70 is equal to 1 times standard deviation plus mean. Now that we have two equations, we can solve one variable in terms of the other variable by elimination process. So let's start with the first equation, such as 40 is equal to negative 2 standard deviation plus mean, and the second equation is 70 equals 1 standard deviation plus mean. By elimination, we can solve for the value of standard deviation simply by subtracting the first equation from the second equation. So we will have 70 is equal to 1 standard deviation plus mean minus the second equation, 40 equals negative 2 standard deviation plus mean. Take note that when we subtract, we change the sign of the subtrahend. So positive 40 will be negative 40. Negative 2 standard deviation will be positive 2. And then this will be negative. Since they are now unlike sign and they have the same terms, this will be 0. 70 minus 40 is 30 equals, it is also like terms, so 1 plus 2 is 3 standard deviation. Solving for standard deviation, we'll divide both sides by 3. So, standard deviation is equal to 10. For us to get the mean, we will just substitute the value of the standard deviation from either the first equation or from the second equation. Let us substitute it at the first equation. 40 is equal to negative 2 standard deviation plus mean. So 40 is equal to negative 2 times the value of the standard deviation, that is 10, plus mean. So 40 is equal to negative 20 plus mean. Isolating mean, and for us to get the mean, we'll have 40 plus 20 is equal to the mean. And 40 plus 20 is 60. 60 is equal to the mean. Okay. So for our second equation, for us to verify if we still have the same answer even if we use the second equation, we'll have 70 is equal to 1 standard deviation plus mean. So we have 70 is equal to 1 times the value of the standard deviation, that is 10, plus mean. 70 is equal to 10 plus mean. Using addition property of equality on both sides. So 70 minus 10 is equal to 10 minus 10 plus mean. So this will be 0. This is 60 is equal to the mean. So they both agrees that mean is equal to 60. Therefore, the answer to the given question, number 1 and 2. Number 1, the answer is, it is possible to determine the population's mean and standard deviation given only the raw score and its corresponding score. Number 2, the mean and standard deviation of the population is 60 and 10 respectively. That ends our discussion. And for our references, I'll use the statistics and probability, the pivot copy. And for those who are new with my channel, Juliet B, please don't forget to like and subscribe. And I would like to say thank you for watching, and may you have learned a lot from this lesson. Don't forget to answer the task given in our G class. Goodbye!